Welcome, everyone, to another episode of the Global Exchange. On this episode, we have Team 30329 Mechanical Masterminds here with us to provide an intro to Pedro Pathing. Take it away, y'all.
Yeah, thank you so much. My name's Alex. I'm part of 30329 Mechanical Masterminds, and we recently went to regionals, which is really cool. Adi?
My name is Adi, and I'm also part of Mechanical Masterminds. All right.
So, looking at an overview of what we're going to do, we're going to start with what is pedropathing, then why use pedropathing, what you would need to use pedropathing, and then to wrap it all up, what is odometry. So, I can start on what is pedropathing. So, pedropathing is a path follower developed by FTC team 10158. And basically, what's really cool about pedropathing is it uses Bezier curves and PIDF control and also centripetal force correction to follow paths more smooth, fast, and accurate than previous systems. The really cool thing about pedropathing is it corrects as it's moving, and you'll see that also with it reacts instantly to external forces, as shown in this animation. So the next is why use pedropathing. So first, as a rookie team, of course, it was a lot getting into FTC. I think having the resource to have a visualizer to see on a bird's eye view of a field what the path is going to do really helped us in that developmental stage. And really, what's a big pro compared to other pathing libraries such as Roadrunner is that unlike Roadrunner, Pedro pathing corrects immediately, like I said. So in this animation, you see on the top, this is kind of what a Roadrunner software would do. As you see, um the robot uh gets hit by external force and then at the end it corrects. Now, what's different with pedropathing is that it will correct immediately after the external force, which means you don't risk maybe hitting a game element or something like that. Another cool thing is that it corrects heading throughout the path. The way Roadrunner works is it creates a motion profile in the beginning when you initialize your programming. So it's not going to be able to correct itself as it goes on through the path, unlike Pedro. And then also since it's not correcting at the end of the path, it saves more time at the end. Um, And Roadrunner, it's legacy software, so it's not being updated for new seasons, and that means that bugs still in Roadrunner won't be changed as
So what you will need to use Pedro pathing is a reliable localization system. So whether it be odometry, um, working with a working omnidirectional drivetrain, so Mechanism or Serve as an example, and you need to be using Pedro pathing. I mean, sorry, Ender Studio, because Pedro pathing doesn't work with onboard driver blocks, and a proper dashboard like panels to tune your PIDF. So, what is odometry? Odometry is a type of dead-wheel localizer system that uses encoder ticks to see how much a wheel has rotated that is contacting the ground in order to figure out the robot's position. And Alex, can you play the? Oh, you did. So basically, this little thing at the bottom is just kind of showing like the odometer moving and the amount of encoder ticks increasing, which like helps keep track of the robot's position.
Yeah, and important to add is that odometry doesn't just have to be dead wheel localizer. It can also be any sort of sensors that a robot wants to use to detect um where it is. Now why teams use dead wheel localizers is that many teams use mechanism wheels and taking the straight encoder values from the drivetrain motors um you risk localizing not really consistently and with quality. So that's where dead-wheel localizers come in. I know teams who use optical sensors, like what would be on the bottom of a mouse, to localize, and I also know teams who use a pinpoint, which is what we use with an odometry. It's also important to add that you also have the option to use vision software such as Limelight with Megatag, or using OpenCV to give a good idea or update the odometry with Pedro Pathing. So, is there any questions?
Yeah, so some questions that came to mind there was you talked about odometry pods, but how are they useful on the robot and why do you need them with Pedro?
Yeah, so odometry pods are useful because instead of relying on a force localization system such as just drive motors. I'm gonna use that reference a lot because I know teams struggle with that. You get a more consistent and more reliable form of localization. Now, what was the second part of that question you said?
Uh, why do you need it on your robot for
Yeah,
Pedro?
so teams don't need odometry pods for Pedro. It's recommended, and most teams do. But I know teams who also use optical sensors, such as I'm pretty sure the Spark Fun was used from a lot of teams.
So
Any
if
other
you don't
questions?
have any
Sorry.
tracking software with the odometry pods, do you still need a source to get the positioning on of your robot on the field?
Yeah, yeah,
Hmm.
you would definitely need some sort of source, whether that be using motor encoders and updating it with computer vision or any sort of fusion that teams want to do.
Okay. And also, you talked about Roadrunner earlier. In that, is there
Mhm.
a major difference between Pedro and Roadrunner? And can you just slightly explain Roadrunner compared to Pedro a bit?
Yeah, certainly. So I'm just gonna go back to that slide here. So the reason also one big change that I forgot to add is that Roadrunner tends to not be as good with projecting centripetal force as petropathing. So tidal curves may impact Roadrunner as compared to Pedro, which is correcting all the time. I also want to add that Pedro can make paths on the fly. So this is seen in teams who are doing an auto base poke. So we had a button which would take the current position and create and make a path to the pose of the center of the base zone. And when we pressed a button, it would automatically go and poke. And Roadrunner wouldn't allow you to do that because it needs to have a motion profile created in the beginning of a program.
Okay. And then, how do you get the Pedro software? So you talked about what it is and why to use it, but how do you get the Pedro software to use it on your robot?
Okay, so in order to use the Pedro Pathing software, you go to Pedro Pathing, um, click Get Started, and there's installation guide, and you just follow that, and then you you can either put it manually or using the quick start. Just basically just follow the directions as already given, and you should be able to find it.
Okay. And then is there something that you have to do to get the Pedro pathing software to work with your robot, or once you download it, does it automatically work on your robot?
Yeah, great question. So I'll just add so um the localization tuning, there's definitely some setup and tuning for constants and tuning all of your values, but it can look a little different. So I'm just gonna pick the pinpoint localizer because I know that's a popular choice. So the first thing is you want to set your offsets. So that's the parallel offset of the pods in relation to the center of the robot. So teams who poorly do this may see some drag as a match goes on. So for example, we had a strafe parallel offset a little too much, and everything was shifted too much to the right or to the red line side. Um, and after that, encoder resolution. So if you're using a full ball odometry pod, GoBuilder already tuned this for you, so you don't need to do any extra setup. And then encoder direction. So Pedro comes with a tuning program that would just run like any other op mode. And basically you run localization test, and if you move the robot forward, the X coordinate should increase, and if you move it left, the Y coordinate should increase. So it's important to add that this might be different as other localization systems use different pods and different values to determine where it is. And you would just add a modifier to your pinpoint constants in the constants file of pinpoint of Pedro Pathing. I I
Thank
don't
you.
know if I can get you a example of that, but the constants is file is where a lot of that setup happens. So after that, there's automatic tuners, which is just for like forward velocity, lateral velocity, and then zero power acceleration. So this makes sure that your robot can maintain its velocity throughout the paths, and then also figure out how much it decelerates after it moves forward after power is cut, so that it can cut it earlier so it doesn't overshoot. And then of course you have your PIDs, but that's a little more complicated. And there's already docs on Control Alt FTC and the Pedro Pathing docs on that. So I'm not going to go really into that.
No, not at all. That was really informative. We ourselves, we are looking into getting into Pedro pathing. We haven't yet, and we currently use Roadrunner, so that was really informative. Thank you.
Yeah,
Oh yeah,
no
thank you
problem.
guys. Thank you guys so much for having us.
Mhm.
It's a really great initiative you guys have. And yeah, I hope we can connect with Blue Bananas Robotics soon. Thank you guys.
Yeah, thank
Thank
you.
you.
And we'll see y'all on the next episode of the Global Exchange.